Okay, I hope you can see the recording right now. And can you see the screen arkadaşlar? Can you see what is on the screen right now? Can you see what do you see on the screen? Yes, you can see what. Let me do this. Şöyle hepinizin bir chatini bir göreyim. Evet. So there are 3 questions, and in this question, if all possible samples of size 64 are drawn from a normal population with equal mean to 70 and standard deviation 14, what is the probability that a sample mean X bar will fall in the interval, this and that? Assume that the sample means can be measured to any degree of accuracy. So, arkadaşlar, this is, you don't need this 70, 14, or 64, as you know. We did something like that before in the class. If you remember, we were doing this. Let me do this again here. X bar should be greater than mu X bar minus 1.8 sigma X bar and less than mu X bar minus 0.2 sigma X bar, right? So this is what the question asks from me. So how will I do it? If you remember, we were converting everything to Z, right? So Z lower bound is going to be mu L prime or bar minus 1.8 sigma X bar minus mu X divided by sigma X bar, okay? So this is the lower limit that the question asks from me. It is asked here, the lower limit, and this is the upper limit. So in terms of the lower limit, I use this. If you remember, Z was equal to X bar minus mu X divided by sigma X bar, which was equal to sigma X divided by root N. You remember all these, right? So what I'm doing is I'm putting this lower bound to this formulation, Z formulation. Now, from the central limit theorem, I know that these two are equal, so they cancel out. What do I have? Minus 1.8 sigma X bar divided by sigma X bar. These will also be going, so there is nothing left. So what do I have? Minus 1.8. Okay? I didn't use any 70, 14, 64. I didn't use any of that. And I directly implemented the Z formulation, going from X bar to Z formulation, okay? This is what we have done here. How about the Z upper bound? Can you tell me the Z upper bound immediately right now? What is Z upper bound, arkadaşlar? Can you tell me? Yes, directly I can write 0.2 from here. This is 1.8, this is 1.2. So I will draw my Z graph here, okay? And what does it tell me? This is 0, this is minus 0.2, this is minus 0.8. So what is being asked, arkadaşlar? Probability of my X bar being between these two, right? So what is the probability of Z being less than minus 0.2 is gonna be this area, right? The whole area. What is the probability of Z being less than minus 1.8 will be here. So if I take the difference between this and the area below minus 0.2 to below minus 0.8, I will find out the solution, right? So I will take a look at the Z table, and from Z table, 0.2 is gonna be 0.42007. This will be from Z table 0.0359. So if I take the difference, I will obtain 0.848. Okay, this is going to be the probability of this x bar value being between these two values. These values changed in your questions. Each question may come with different numbers, and these upper and lower bounds have changed. So your results will be changing, but the probability for this question will be something like that. So we should be able to read the Z table and read the Z table for these two values and obtain the P value, okay? I guess it is clear. There is no problem that is, Hocam, why didn't we multiply the root of the sample number? This is an important question. Thank you, Muhsin. Actually, what is being given to me is mu x bar minus 1. Sigma x bar, you see? So this is already sigma x bar. It is not, this is not given like sigma x, it is not said here sigma x, but it is sigma x bar, okay? So that's why I will not do anything here, because my formulation is x bar minus mu x divided by sigma x bar, and x bar is over here, x bar is over here. There is no need for doing any calculations by dividing by n or something like that, okay? So sigma x bar is already standard error of the mean. If sigma x is given, then if I need to find out sigma x bar, then I would say sigma x divided by root n, okay? But this is what I'm after. This is what I will use in my calculation. That's why I use this directly. Is that clear, Muhsin? Is that clear? Yes? Okay. Let me move to the next question. Now, there is like batteries used in the electronic games will last an average of 32 hours. Let me write the mu x is equal to 32 hours. To maintain this average, 25 batteries have been tested each month. If the computed T value is between minus, if you remember, T was here, T 0.025, the area under this is 0.025, the area here is 0.025 will be again 0.025, right? We know these. So it is what is left, 95% will be in between these two values, right? So this is being asked. Okay, the firm is satisfied with its claim. What conclusion should the firm draw from a sample that has a mean? So x bar is equal to 34.4 hours, and a standard deviation, this is from 25 samples, 4 hours, right? So if you remember, T was equal to what? X bar minus mu x divided by the sample variance divided by the number of samples, root of samples. 34.4 minus 32 divided by 4 divided by root n, which is 25. What is left? 2.2, 2.4 divided by 4/5, which is 3.0. So T is 3.0, right? So I found T as 3.0. So for this sample and variance, and for the observed mean, I found my T as 3. So what is being asked again? Here, what is the value here? We have to be careful while looking at my table. I need what? I need n-1, which is degrees of freedom, which is 24. So for 24, we write it like that, 24, comma, 0.025, which is equal to 1.711, okay? So this is given. I take a look at the t-table. Let me show you the t-table. Let me show you the t-table arkadaşlar. This is the t-table. What do I do? Here, I will take a look at alpha over 2. So here is 2 tail. Here, I should be looking at this one. And I will go down. And 24 is going to be 24. Am I doing something wrong? Am I looking at something incorrect? Let me check here. From the book, I found this to be 1711. I will check that later. So I found T as 3. Did you find it as 3 too for your questions? I don't know. It may change from question to question. So I found T as 3. And here, the values are 1.711 and 1.711. So what does it say? What does it tell me? This sample set, this sample is like here, very far away, right? Somewhere here. So it is away from being in this region. So I would not be satisfied with this claim, okay? So it is out of what we wanted. So that's why we will not be satisfied with the claim. So do you have any questions regarding this example, regarding this quiz question? So we have this given to me, given to me, given to me, and the number of batteries have been given to me. That means I can apply this formulation and find this as 3. The probability of obtaining 3 is very low when we compare it with this given values, okay?
Hocam,
Yes, I'm going for, efendim Ömer.
Could you repeat the part that we satisfied or we don't satisfied?
What does it say? If the computed t value falls between this and this, falls between 1.711 and minus 1.711, if the t value that we found was between these two values, then the firm would be satisfied with this claim. But
okay, hocam, I got it.
I'm finding 3, so that's why I say the firm shouldn't be satisfied with this claim. Okay? So the last question is, an experiment is conducted to compare maximum load capacity in tons for 2 alloys, A and B. It is known that the 2 standard deviations in load capacity are equal to 6 tons. So I write it here, sigma A is equal to sigma B is equal to 6 tons, okay? The experiment is conducted on 40 specimens. That means I have n equals 40 for each alloy. And the results are X bar A is equal to 62.2, X bar B is equal to 58.6, which says the difference between two alloys, the averages, the mean values are different in 4. The manufacturers of alloy A are convinced that this evidence shows conclusively that mu A is greater than mu B. The average of alloy A in terms of load capacity is greater than the load capacity of B in terms of average load capacity, and strongly supports the claim that their alloy is superior. So they say that A is better than B because it is found as better, right? So it's higher. But what B guys say, this is the populations are equal, but it doesn't matter that we have a 4 tones difference. We shouldn't be worried about this small difference. It doesn't mean that A is better. That's what they asked us. Okay. So what I'm saying is, tamam, teşekkür ederim. So what I'm writing here is that if you remember from the book again, I will write my Z distribution. Why Z distribution? Because I know A and B. Okay, standard deviations are given. I know standard deviations. I know the sample means. So I can use why do I use Z arkadaşlar? Because I know sigma, right? Sigma is known. Sigma is known. So then I use Z. If sigma is not known, then I would use t-test or t-distribution, okay? So we always assume that they have either normal distribution, the x bars have normal distribution, or the number of samples in the calculation of x bars are high, which is related to the central limit theorem, okay? Do you remember all these arkadaşlar? So that's why sigmas are given. I will be applying Z here, but this time what will I do? XA minus XB minus mu A minus mu B divided by sigma A divided by sigma A, okay? What is this? Sigma A and sigma B, they are already given. So I should divide it by root n, which is 40, plus sigma B divided by 40, which is 6 and 6 here, right? So what is the value of this part? 4. What is the value of this part? We are assuming that they are equal, so it should be 0, divided by what? 12 over root 40, right? So which is something like root 40 divided by 3. Am I doing correctly arkadaşlar? 1, 3, root 40. What is root 40? Something like 6 point something, right? 6.3. So 6.3 divided by 3, which would be 2.1. I'm not using any calculators. You should be using it. But I'm just finding the Z value here, which is 2.1. Then I go and say probability of Z being greater than 2.1 is what? It is very small, 0.007, something like that. So that means the claim of B, the claim of alloy B manufacturers is not true, because the difference is significantly high, okay? So that's why we would say if we have this distribution, now my difference is somewhere here, which is 2.1, and the area above here is going to be 0.007. Even if we say about 0 in response. So I don't know if the system says very close to 0 is fine arkadaşlar. Actually, it's not 007. It is 7 in 10,000. So it is very close to 0 actually. If you write 0, it should also be true. No problem with that. Okay. So you got the message, right? So what would we say? Close to 0.007. Do you think data support LOA? Yes, the data supports LOA. Since the probability in A negligible, the experiment LOA, I don't know, I don't remember what it was writing here. What was writing here, arkadaşlar? Probability in A is negligible. The experiment supports LOA. Yeah, that's true. Thank you very much. So the result should be supports LOA in is negligible. The probability in A, we found something close to 0.0007, which is very small. So is negligible, and the experiment supports LOA. Why? Because they are significantly larger than LOB in terms of load capacity. Okay, you got the main message, arkadaşlar. The probability in A is negligible, right? Am I correct? Is negligible because it's very small. Negligible means you can neglect it. Don't worry about it. So the probability of this being greater than 4 is like the difference between them is greater than 0, is highly supported. So that's why it should be negligible, and the experiment supports LOA. Okay, so I hope this is fine with you, and I guess we got the main message here. Is there any questions regarding the quiz and the topics in chapter 8? Now I would like to go and talk about chapter 9, which is very similar actually with what we have discussed before in chapter 8. There are again T, Z, those kind of things, and comparisons, those kind of things. Okay, I'm done with the solution of quiz questions. I would like to go and talk about the chapter 9 right now. Are you ready, arkadaşlar? Are you with me right now? Yes? Okay. Let's move on and come here. The chapter 9 is headed, the heading of chapter 9 is 1 or 2 sample estimation problems. We will estimate some things, okay? I will talk about these estimations. Let us get started and see what is going on. If you remember, arkadaşlar, we always talked about the unknown population parameter, right? We always talked about unknown population parameter. So we don't know the actual mean. We don't know the actual proportion in the population because it's a big population. We cannot reach everybody, and we don't know it in very different problems. So we would like to estimate them, okay? If we can estimate what these population means are, population proportions are, then we might come up with some decisions accordingly, okay? So if you we are trying to estimate like the proportion of Turkish college students who have a smartphone. What is something that we expect? The proportion should be very high, right? But we may not know the exact population mean directly. We should be conducting certain kind of sampling, which we discussed earlier, or we might be, and we are educationists, okay, and we are trying to find out the mean, the unknown mean number of days it takes first graders to learn how to read and write, okay? So we might be asking different questions in terms of population proportion or population mean, and we would like to estimate them. What should we do for that? We need to take random samples from the population and use the resulting data to estimate the value of population parameter. What was the population parameter, arkadaşlar? Their actual population parameters were mu, sigma, and such. And what were we trying to do? We were trying to find out the sample mean or the sample standard deviation, right? So these are some estimates, and we are trying to do some good estimates in this whole chapter 9 right now. We will learn how to find out good point estimates for population parameters. You will hear that a lot, point estimate. Point estimate means you are trying to find out mu. This is a point. This is the mean, okay? This is the mean. That's why it's called point, okay? Nokta, just one value. Or X bar is the estimate for this, right? So, for example, P, the population proportion is what I'm after. But from the samples, I may find out the population proportions or estimate population proportions from the samples. This is called the estimate. This is called the real population, okay? This is called the real population parameter. This is called the estimate. We also told it like statistic, right? Do you remember this statistic? Statistic like X bar and proportion kind of thing. So we will try to learn how we can find out good estimates, okay? So what did we do before? We took samples from a production line. We asked questions. We performed surveys. And these are some random variables, X1, capital X1, capital X2, and capital Xn. For example, each capital X would be one person, okay, the answer of one person, and it might be a random outcome, and the result, the answer of that person might be X1, 1 or 0, yes, no, okay? Or we might be after the number of customers in the shop in 1 hour might be the random variable, and the value 5, 10 might be the random sample, specific random sample we have, okay? You remember those kind of things, right? We have the random variables as capital uppercase letters, and the random values, the values, observed values are used, are represented by lowercase letters, okay? Let's first talk about the range. You remember the range, right? If I'm after the average mean grade point, GPA of all college students in Turkey, there are 8 million people now having their college degrees, trying to obtain their college degrees, and I cannot go and find out the mean grade point average, but I know that the range is between 0 and 4, right? If we are using American system, that we would be using between 0 and 4. So I would know that my mean will be between 0 and 4. This is called parameter space, okay? I know that my parameter, my mu, my mean grade point average will be 4. So it cannot be 5 or 6 or 10 or -5, okay? So this is something we know beforehand. For example, if we are trying to find out the proportion of students who smoke cigarettes, then the parameter space will be between 0 and 1, right? Or 50%, 0.5, those kind of things that we will have. There is no like 110% of the students smoke. There is nothing logical here, okay? So this is critical for us. If you are not Muhsin, it is between 0 and 4. Even if you are Muhsin, it is close to 4 arkadaşlar. You may not be over 4. So everybody will be below 4. In some American universities, it may be 4.1 because they have a grade called A+, which is something over A, okay? If we had such system, we might have GPAs greater than 4, yes. Evet, now I will be talking about some estimators, which we also covered before. If you remember, what was point arkadaşlar? Point. Why do I call point? Evet, please write on the chat. Why do we call this as point? because it is just a number, not an interval, okay? It is just a number, like the mean, like the variance, like the proportion, okay? So this is why we call it points. Everybody got this idea, arkadaşlar? Point is like we will be estimating the population mean, population variance, population proportion. So that's why they are called points. In the later part of the course, we will be talking about, yes, just nokta. If then we will be talking about an interval, okay? We will tell this is an interval. We will try to estimate intervals then, okay? So this is called point. This is why we call it point estimator. Okay, this formulation is for point estimators of the population mean, right? We obtain different values, add them up, divide by n. This is what we have done so far. This is the average point estimator. Something that we know before. Bakın burası önemli. The point estimate is theta. You will be using this theta in your book also. Point estimator of x, okay? This is the point estimator of x. What is x here? What is theta here? Theta will be mu, okay? So mu will be theta over here. What are we trying to do? We are trying to estimate the mean by using this formulation, which is called point estimator, okay? This is a formulation we use to estimate the estimate theta, okay? So how about this? If I have yeses or nos, success or failure, male, female kind of situations, then the proportion, population proportion, P, might be estimated using this formulation, right? Zeros and ones, add them up, divide by n. So you have 0, 1, 1, 0, 1, 0, 1, 2, 3, 4, 5, 6. So 3, I will add all of these, divide by 6, which will give me 5.5, which means 50% of the answers are yes, right? With what I'm trying to do is, I'm trying to find out the population proportion by using my data in my hand, which we have discussed before many times, okay? So here, this is the point estimator of the variance. If you remember, we did that before. This is the point estimator. I will talk about this next week, why we have 1 over n minus 1. We have it in the book. So you may check the book for this explanation. And I will try to explain it next week to be more concise, okay? So this is what we have. We know it beforehand, okay? So some easy examples. Point estimate of mu is 3.12. I have obtained 88 GPAs from students, and then I found out that the point estimate of mu will be 3.12. Okay, so this is what we have done before. Then I will ask students if they have any chronic diseases or not. If they have no chronic disease, they will say 0, no. If they have chronic disease, they will say yes, which is 1. So then I will find out the point estimate, which is called sample proportion, right? This is called sample proportion, which we did before, sample proportion. Örnek oran, örneklem oranı, sample proportion. This is called sample mean, örnek ortalaması, sample mean, right? So, örneklem ortalaması. So this is what we can do. It's easy, just repetition of what we have said before. This is something we talked before, but it's in a different context. I would like to talk about confidence interval, okay? And why talking about this, I think the topic will be more clear in your minds when we talk about confidence interval, okay? We would like to, when we use sample mean x bar to estimate the population mean mu, how can we be confident that X bar is close to mu? So we are finding from our samples, we are finding X bars, but how confident that we are, how can we be confident that this X bar is close to mu? Okay, that's what we will be doing in the next couple of minutes. Okay, so if we look at here, so similarly, how can we be confident that sample proportion is close to the real population proportion? Okay, in that sense, we will be talking about confidence intervals, eminlik aralığı, eminlik, okay, confidence. How confident I am in this decision. Okay, so we will try to find out these confidence intervals. This is how we do it, arkadaşlar. We say, I think we did similar things in chapter 8. That's why it's a lot easier for us to understand chapter 9 right now. So we will be finding out a lower limit for our mu. If you remember, what was this? What was this mu? What is this mu, arkadaşlar? Population mean, right? Population mean. What is this L? Lower bound, lower value between which we can be really confident, we can be really confident the population mean falls, okay? Really confident. We will be talking about this really confident in a minute, okay? So we will be talking about the lower bound, lower value, or upper value. And I will say, I am this much confident that the population mean lies between these two values, okay? This is what we will be talking about. As we talk more about the examples, it will be more clear for you. Similarly with the proportion, population proportion. Here the values might change, but the values here should be between 0 and 1. L might be 0.05. For example, U might be 0.10 or something like that if we determine L and U. These values might be 50, 60. So proportion should be between 0 and 1, but this value might be anything, any number, okay? So we will be talking about these intervals, arkadaşlar. These intervals are our confidence intervals, okay? Confidence, I am confident in this interval. So this is what we will be talking about in the next slides, okay? And if you remember, we were drawing this T or Z distributions, okay? We were drawing this Z distribution like that. And then we were saying, this is my Z value, Z alpha value, and the area below this Z alpha value is alpha. That's what we were talking, right? So we are now put it in the context of confidence interval for the next 20 minutes, okay? So that's why it is critical for you to grasp the main idea. Before we talked about alpha was 0.90, alpha was 0.95, alpha was 0.99, okay? Which we will talk about them as confidence coefficients, alpha, okay? Alpha, confidence coefficients. Or we may say confidence levels, which is like 90% when confidence coefficient is 0.90, 95% or 99%, okay? We have two things, confidence coefficient or confidence level. One of them is described as 1 minus alpha, okay? 1 minus alpha. So if I say alpha is 0.05, then this part will be 0.95, okay? So if alpha is 0.25, then this will be 0.975, okay? So this is what we will be talking about. We will be talking about alpha and 1 minus alpha, and 1 minus alpha is highly related with confidence intervals. In questions, you will see confidence intervals or alpha values for you to use. Okay? Bakın burası önemli. Burayı anlarsanız gerisi çok kolay arkadaşlar. So, what are we saying when we say confidence interval is 95%? Bakın, upon calculating a confidence interval for a mean, what are we trying to do? I am trying to find out a confidence interval for my population mean. Okay? I don't know exactly the population mean, but I'm trying to estimate the population mean. How will I do it? I will come up with a confidence interval. I will tell you an interval in which I will say I am 95% confident that %95 oranında eminim ki the population mean falls between this lower bound and upper bound, lower value and upper value. Okay? So here today, right now, we will be talking about this interval. Using this interval, we will say I am 95% or 90% or 99% confident that the population mean falls between these two values. Okay, so that's why we will be talking about confidence interval. So if we are more confident, then if you would like to be more confident, then our interval should be bigger. Okay? Bakın burası önemli. If my confidence interval is high, if the confidence interval high, I would like to say I am 99% sure that the grade that Bülent will take from the quiz will be between 30 and 90. Right? I can say that, right? 99% confident. But if you want your intervals to be less, then you say I am 95% confident that Bülent may take something between 70 and 80. Okay? Now my interval is smaller, okay, for 95% confidence, but for 99% confidence, my interval is larger. Why? Because I want to be more confident. I should be increasing my interval in that sense. Let me give you one example on that, okay? Let me give you one example on that. For example, here, I'm going fast, but let me tell you here. For example, if I say I am 95% confident that the average amount of money spent monthly on housing rent, okay, is between 500 and 3,500 Turkish liras. Is it a good estimation arkadaşlar? Is it a good estimation? Like between 500 and 3,500. It's
No.
not a good estimation, right? I want to be more specific. That's why I want to have a smaller interval instead of obtaining a larger interval. Okay? That's why there is a relationship between confidence interval and confidence level. Confidence level is highly related with confidence interval. Okay? If confidence interval increases, my confidence interval will be larger. Okay? Confidence interval higher, confidence level higher, confidence interval larger. Okay? So that's what we should be careful about, and I will come back to this point in a minute. Okay? Evet, everybody is with me, guys. Do you understand what confidence level is? confidence interval. Did you understand this part? Arkadaşlar, we can be 95% confident that the population mean falls between these values. Okay. Okay, let's go. Do you remember this kind of a chart? Yes. We said alpha over 2, okay? And then we said z alpha over 2, z minus z alpha over 2. And between these two values, I will have 1 minus alpha, okay? So we will use these alphas or 1 minus alphas in our confidence level calculations, okay? So this is what? What do we call this, arkadaşlar? What do we call this? Confidence coefficient, right? Confidence coefficient. So 1 minus alpha will be our 95%, 90% or 99% confidence levels, okay? Coefficients like that, levels 95% like that. We will be using normal curve, standard normal curve. If we know something, if we know sigma, we will use standard normal stuff. If we don't know sigma, we will use S instead of that, and we will use T distribution. It was something like that. If you remember, it was a little bit like that, and the shape changes with respect to n-1, right? Degrees of freedom. So we are doing similar things, but in a different context. So that's why we should be careful in that. It's very easy for you to grasp and understand what's going on. Evet. So if you remember, we did this before. The X bar, the sample mean, has a distribution of normal distribution with a mean of mu, because this says this is something from the central limit theorem, and this was from, again, central limit theorem with, what did we call this thing here? Standard or error of the mean, right? Standard error of the mean. Square is something like, if we go take this and take the square root, this was called standard deviation, and also standard error of the mean, right? So we did that before. If you remember, we were converting everything to 0 mean, 1 standard deviation situation, okay? Let's move a little bit further. If my population variance is given, if I know my population variance, then I will use this formulation, arkadaşlar. Bakın, this is called confidence interval. It's very easy. I will give you alpha. I will give you alpha value. I will give you, or you will find out the sample mean from the data. And then from alpha value, you will find z alpha over 2 from the z table. And then sigma is already known, so it is given to me. And I will put it over here. Number of samples I used in my data is here. Similarly, right? This is called standard error of the mean. So what is my interval about? X bar plus and minus z alpha over 2 times standard error of the mean. Okay? So what do I say? For example, alpha is 0.05. Okay? Alpha is 0.05. What do I say? I am 95% confident that the population mean lies or falls in this interval. What kind of an interval is this? X bar minus z alpha over 2 standard error of the mean, and X bar plus z alpha over 2 standard or error of the mean. So this is my interval, okay? So this is my interval, and what I say, I am 95% confident that the population mean falls in this interval, okay? This is what you should remember, okay? What do we need for that? Let me give you one example, okay? and I'm going to finish after this example. So I have performed a random sampling on police officers. They are continuously inhaling automobile exhaust fumes, duman, araba dumanları, okay, exhaust dumanı in Taksim, had an average blood lead level, kanda kurşun oranı, blood lead level, concentration of 29.2 milligrams per deciliter. Okay, this is something that doctors have found out. Assume X, the blood lead level of randomly selected policemen, is normally distributed with a standard deviation of sigma equals 7.5. What is given to me, arkadaşlar? What is given to me? What is this value? What is this value? What is this value? Gençler, X bar, yes, X bar. So this is not population mean, but X bar. You see, constant inhalation of had an average blood level concentration of average. Okay, so this is my sigma. Okay, it is also given to me. Historically, it is known that the average blood lead level, so out of these 126 police officers, I found this, okay? So X bar will be 29.2. This is not population mean, okay? This is coming from 126 police officers. That's not population mean. It is sample mean, right? Sample mean. So how about this one? So this is population standard deviation, right? It is given to me. It is already known from previous, let's say, observations. Historically, it's known that the average blood lead level concentration of humans with no exposure to automobile exhaust is 18.2. Now it is right. It is mu equals 18.2, right? Mu is something like that. Is there convincing evidence that policemen exposed to constant auto exhaust have elevated blood lead level concentrations? This is what is asked. Similar to what we have done before, right, arkadaşlar? Similar to what we have done before. Just the question type is changing, but this is what we are doing constantly in the last couple of weeks. So let us solve with 95% confidence level. Then I will say this is 0.95. Alpha is 0.05. And alpha over 2 will be 0.025. So from the Z table, I will find out Z equals 0.025 as this value, okay, minus 1.96 and plus 1.96. If you remember, what was given to me, arkadaşlar? X bar was 29.2. Mu was what? 18 point, what was it? 18.2. Okay, X bar, sorry. X bar will be 29.2. Mu will be 18.2. And standard deviation will be what? What was it, arkadaşlar? Sigma. What was sigma? Do you remember sigma? Nobody remembers sigma? Arkadaşlar? Anybody remembers what sigma was? No? Let's check. It was 7. Let's say it was 7. Okay. Mahmut says sigma 7 or 5. Ömer says 5. Okay. Let's do it. How will I solve this problem again? I will change my X bar to Z, arkadaşlar. This is what you know beforehand. Okay. Use this formulation. Divided by root n. What is X bar minus mu? It is what? It is what? 11, right? 11. 11 divided by, let's say, 5 or 7 divided by how many people? 126 people. Okay? So it is like this z value. Let me show you. It was 7.5. Okay? So what are we doing here? What is the goal here, arkadaşlar? I am trying to find out the interval. How do I find interval? Using this formulation. Okay? X bar plus minus this. This is already given, 7.5. This is already given 126. This is already given 1.96 from the Z table. I know that this is already given. Okay? So, what is my interval? 29.2 minus this, 29.2 plus this. So, my interval is this. So, I am confident that, I am 95 confident that the mean blood lead level concentration of all policemen exposed to constant auto exhaust is between this. I am 95 confident. What was the actual without any exposition? 18.2. So this is not here. So I can say that constant auto exhaust exposition will increase the blood lead level in policemen in Taksim area. Okay, this is how we approach this problem. Okay, so in previously what we were doing, arkadaşlar, we were finding z from x bar minus mu divided by this, but now what are we doing? X bar minus z alpha over 2 times standard error of the mean and plus and minus. So this will be my interval for the confidence. Okay, this is confidence interval. Okay, it's time to quit here. I will share the slides with you, and I want you to take a look at them. It's a very easy task topic, this chapter, and I'm sure you're gonna learn it very easily. And on Monday, I will do some exercises, okay? I want you to go over the slides here. I want you to go over the slides in terms of factors that affect the interval, confidence intervals, and those kind of things. And we also will talk about, I want you to take a look at this T interval also for a mean. Okay, and there are some nice examples here. I want you to look at these slides, and then on Monday we will be exercising on the questions that we have in our book. Okay, everybody got the idea, arkadaşlar? You are with me. Nobody has any problems with following the situation. Please take a look at the slides and come back prepared on Monday, so that we will be solving questions much more easily, okay? I hope this was an efficient session for you, and I wish you a nice weekend. Hope to see you on Monday, guys, okay? See you on Monday, and I'm ending this session right now.